Hi, I'm Chris from Glad Science and I'm glad to see you. This is the second video in my cell series. To see the first video on galvanic cells, check out the link in the description below. In an electrolytic cell, an outside source of voltage is used to force an unfavored redox reaction to take place. Most electrolytic cells occur in aqueous solutions which are created when chemicals are dissolved in water. Either ions or water molecules can be reduced and oxidized. So let's take a closer look at this example. So in an electrolytic cell, you have two half reactions. You have one, which is the oxidation, and you have the second one, which is reduction. In the oxidation half reaction, you have copper solid goes to copper 2 plus aqueous plus 2 electrons. And this electric potential is negative 0.76 volts. In your reduction half reaction, you have zinc 2 plus aqueous plus 2 electrons goes to zinc solid. And your electric potential is negative 0.34 volts. So your entire redox reaction, which is zinc 2 plus copper goes to zinc plus copper 2 plus, is in total negative 1.10 volts. So here you have a diagram of this reaction. In one beaker, you have the zinc cathode in a zinc 2 plus solution. In the second beaker, you have a copper anode in a copper 2 plus solution. Here is something called a salt bridge. In the salt bridge is a solution, which in this case is NaCl. In the beaker containing the cathode, you have the cation flowing into the solution. In the beaker containing the anode, you have the anion flowing into the solution. So the cathode and the anode are connected by a single wire in which electricity flows. Because electrolytic cells need an outside source of voltage in order to force this reaction, we have a voltmeter and a battery right here in the center. So you have this battery forcing the electrons from the anode to the cathode. So in this reaction, the copper anode will dissolve away and become copper ions, and the electrons will flow into the zinc solution and form additional zinc on the cathode. So remember, in this unfavored redox reaction, in this electrolytic cell, your electrical potential will always be a negative number. In this case, we have negative 1.10 volts. And remember, just like in galvanic or voltaic cells, you have the an-ox red cat rule. And remember, just like in voltaic or galvanic cells, you have this little trick to remember what happens. At the anode, oxidation occurs, and reduction occurs at the cathode. So thank you for checking us out, and I'm always glad to be of help.